This is the third and final lesson in the Pythagorean Theorem unit in Math 8. We're going to be using the Pythagorean Theorem again today, but this time to find missing side lengths. So go back and watch lesson 2 if you want to see me introduce the Pythagorean Theorem, but I'm just going to review it really quickly here. When we have a right triangle, and again this only works for right triangles, if we make a square on the side, if we make squares on all three sides, the two smaller squares will always add up to the area of the larger square. We call the side lengths of the two smaller sides A and B. Those are the legs. And then we call the side length of the larger square C, which is the hypotenuse. So we have A squared plus B squared equals C squared. I'm just filling in what I had filled in last time. An area. Okay, so we're going to use this theorem today to find missing side lengths, which is a really useful thing. Often in measurement, when you're trying to find the height of something, when you're talking about distances or building, it's a really useful formula to have. Okay, so here we have a right triangle, so we know it satisfies the Pythagorean theorem. I'm going to just write the Pythagorean theorem here. Okay, and we have the two leg sides, but we are missing the hypotenuse side. And it says determine the missing side length and round to the nearest tenth if necessary. I'm going to actually switch this around. So we're looking for C squared, and it's going to be equal to A squared plus B squared. Okay, so this is C. So I'm going to switch it with X just because in my diagram here it's called X. And it's going to be equal to 3 squared. X squared is going to be equal to 3 squared plus 14 squared. We know this to be true just because of the Pythagorean theorem. Okay, so let's evaluate that right-hand side. 3 squared is 3 times 3, which is 9. And 14 squared is 14 times 14, which is 196. And if I add those two numbers together, I get 205. Now, this is going to be x squared, not x. So if I want to find out what x is, what I do is the opposite operation to squaring. So to unsquare something, I square root it. If I do that to both sides of the equation, it's going to be equivalent, but I'm going to get the value of x. Now, 205 is not a perfect square, so it's going to be a decimal number. I can do it on my calculator. And it rounds off to 14.3. Because it's not exact, you can see I didn't use an equal sign. I used this sort of squiggly. That means I've rounded it off and it's not exact. But 14.3 would be the length of that yellow side there. Okay, let's do another one. This time, the hypotenuse is given to us, but we're missing one of the legs. So when we're missing one of the legs, instead of adding in the Pythagorean theorem, we're going to subtract because I have the larger side already. So x squared is going to be 10 squared minus 8 squared. So we're looking for one of the blue sides. We have the longest side, we have the hypotenuse, and we have one of the legs. So you subtract when you want to find one of the smaller sides. Okay, so let's evaluate that right-hand side. 10 times 10 is 100. 8 times 8 is 64. So x squared is going to be equal to 36. And then we're going to unsquare it to find the length of x. So we can take the square root. And square root of 36 is exactly 6. So this time, and it's going to be in meters. I didn't have to round anything because I was taking the square root of a perfect square there. And that is my final answer. Okay, let's do a word problem. A 13-foot ladder leans up against a building. The base of the ladder is 5 feet from the base of the building. Determine how high up the building the ladder reaches. Okay, so for these, so here's a building. You should include a nice label diagram, and I'll show you what I mean by nice. So we have a ladder leaning against the building. And the ladder is 13 feet long. Okay. The distance to the base of the building here is given as well. That's 5 feet. And we don't know how high up the ladder reaches. So let's call that x. Notice how I've labeled all of the sides here. I've got my nice right triangle with my little 90 degrees in the corner there. So I have the hypotenuse and I have one of the legs, but I'm missing the other leg. Okay, so this is what I would be looking for if I was asking for a diagram. Okay, so because I'm missing one of the shorter sides, I'm going to use subtraction in my equation here. So I'm going to have 13 squared minus 5 squared. 13 squared is 13 times 13, which is 169, and 5 squared is 5 times 5, which is 25. And 169 minus 25 is 144. And then to get the length x, I'm going to take the square root, the opposite of squaring, and I'm going to get 12. So we write a sentence because it is a word problem. The ladder reaches 12 feet up the side of the building. And there we go. That's the end of the lesson.